from Christophe Adami. So thanks for you again.
Okay. Okay, so I will share my screen.
Please share your screen.
Yeah. Okay, are you able to see my screen?
Yes.
Okay, perfect. So, sorry for the late talk. So I will try to make it short. My name is Christophe Adami, so I'm an astronomer at LAM in Marseille. And I will present you the Mistral new spectrograph at OHP, Observatoire de Haute-Provence. So Mistral is the acronym for Multipurpose Instrument for Astronomy at Low Resolution. Okay, first a few technical elements. So we have two main wavelength ranges, a blue-green setting and a red setting. So we are basically going from 4,000 to 8,000 for the blue setting and to 6,000 to 1 micron for the red setting. Our mean spectral resolution is close to 750. For now, we have only a fixed slit width of typically 2 arc seconds. It will change soon. We have an imaging field of view of 5 arc minute by 5 arc minute. And the slit we have is close to 5 arc minute as well. The filter wheel has 12 positions, so one empty for the spectroscopy. And then we have G toward wideband filter and some narrowband filters. We have 2 prisms according to the 2 modes and 2 entrance lengths according to the 2 prisms as well. So here you have basic spectral response of the 2 modes. So you see that for the blue mode, we are mainly efficient between a little before 6,000 angstrom up to 8,000. And for the red setting, it's typically between 7,000 and 9,000. Now I will show you a few examples of the first results of the first spectra and images we got. So these are a sample of the pretty bright stars, few minutes exposure of different types. Okay, some imaging. So we compared the Mistral capabilities with SDSS images. For sure, we do not have the same seeing, but at least we are as deep. To the left, you see that you see the G' band image of a cluster of galaxy, 15-minute exposure, and to the right, you see the corresponding SDSS G band image. To the right, you have an example of a supernova spectrum observed with Michel Denfeld. It was in 2020, typically V equal 19, and it was 1 hour exposure. Then something more difficult. So it was an elliptical galaxy at R' equals 17 point something, redshift of 0.13, a 1 hour exposure, so no emission line at all. And you clearly see the absorption line 5175, etc., etc. Okay. Difficult target also. When you try to detect in imaging compact things inside diffuse things, so you typically have these kind of things. So it's a nebulae with some YSOs inside. So you have several exposure times between 5 and 30 minutes, and you see that you are more or less able to detect those things inside the diffuse component. If you try to make the same image with another filter, GR or even I, you will just see the diffuse component. Now, a few words about the status. So, oops, something is left. And anyway, in September 2021, the instrument was open to community in visitor mode. So the first observations were okay. We still have a few ones before next semester. And the pressure we got for Mistral in visitor mode for the 2021 B semester was 1.4. In March 2022, so for 2022A, the instrument will be still open to community for visitor mode, but also for target of opportunity mode. So for this semester, we will have a pressure of 1.5 for the visitor mode and 2.2 for the target of opportunity mode. Whoops. Okay. Something is not working. Okay. Okay. For now, the raw data are hosted at this address. I can show you some examples after if you want. And we also have a possibility to host the observer final 1D spectra plus some added values, for example, redshift, line fluxes, or things like that, through the ASPIC French service d'observation. So this is a place where you can ask to host your final 1D spectra. Just have to send a request to the person in charge, and they will host it for you. And I have also some examples to show you after if you want. Okay, now a few more words about target of opportunity modes. In fact, we have two target of opportunity modes. The first one is related to alerts, so urgent alerts. So if you need a nighttime occurrence, if you need immediate reaction, if you have the pre or go of the OHP the direction, your observation can start as soon as possible. And it means that typically between 20 and 30 minutes, you can be on the target. And then we have a standard target of opportunity mode. So it's a daytime trigger. This gives enough time for the OHP direction to give a go or a no-go during the day. And then you can have your observation if you got the time before. So to test those things in real time with real data, we submitted two proposals for 2022A, one by Émeric Lefloc et al. About the alerts, so GRBs, and another one about TDs by Stéphane Baza et al. So for standard target of opportunity proposals. Okay. A few words about the transient we already confirmed since last year. So we have 5 supernovae, one cosmic variable, and 2 novae, which were confirmed by the astronomical telegrams you see here, mainly piloted by Michel Dettenfeld. And this is my last slide. So this is the evolution plan. For now, Mistral is still in its first phases. It's working for sure, but we have several things scheduled. So in 2022, we'll have a new guiding. This new guiding will allow a better tracking. For now, we are forced, in fact, to use the native telescope tracking. And the consequence, the price to pay, is we have to check every 15 minutes, in fact, if the object is still within the slit, just because of flexions. So with the new internal guiding, we should be able to have a better tracking than 2 arcseconds every 2 hours. So this would be enough. We'll have a tunable slit width. So for now, the slit width we have is close to 2 arcseconds. And okay, for typical conditions in OHP, it's okay, but if we have bad conditions with bad seeings, it's not adapted, and we lost a lot of flux, in fact. So this will be solved typically next spring. And then we'll have an additional filter slot for visitor filters to be able to put your own favorite filter within the instrument without having to open it. For end of 2022 or 2023, we'll see. We will add another disperser, another VPH, with a resolution larger than 2000. For now, I recall you that we are at 750. Yes, at 700, something like that. This higher resolution mode, this will be on the blue side, in fact. Will allow, for example, to precise some stellar classification, or to precise some supernovae classification, or if you have more standard targets as galaxies or things like that, to access to narrow doublets, for example, O2 or things like that. And then we have the last step. This is still under study, as you see, and it is not easy. We are trying to make a study to design a new entrance lens, a single one, in fact, to be able to observe the blue and the red mode at the same time. For now, if you want, for example, to observe in the blue mode, you have to say it before the run, and then we have to mount manually the blue entrance lens. So we cannot change the lens during the night. It can be done during a run, but it has to be done during the day. So with this new entrance lens, we should be able to do it just with a simple click. So the last point is not yet founded, but it is under study. So it's okay for me. So if you have questions, do not hesitate. Are you still there?
Yes, Leo. Well,
Yeah,
I can...
sorry. Yeah, so Rosa have one question. Thanks.
Yes, I have two questions. The first one is very nice. What's the visitor mode? What's the visitor mode? Because you mentioned that in the observation in one of your first slides.
I'm sorry, the link is not very good. I'm not able what you mean by.
No, before,
okay. This place?
No, I don't know. I don't know where is it.
Elle veut des précisions sur ce qu'est le mode visiteur.
Ah, visitor mode. Okay.
Yes.
Visitor mode is the classical mode. In fact, you make a proposal, you take a plane, and then you come to observe yourself.
Ah, okay. Oh. And the second one, could you please tell us about what the analysis pipeline, or how much time you spend to analyze your data?
Okay. Okay, I can show you for example this spectrum. This is the result of the pipeline we offer to reduce the data. So we have several choices. In fact, you have a quick look during the night, and the quick look is able to compute you a wavelength calibrated spectrum in typically 1 minute. So we were able to generate this spectrum typically 1 minute after observation.
Wow.
Then we have something a bit more picky, a bit more refined, and then in typically a few minutes, you are able also, if you have in hand a flux calibration star, you are able to produce the same thing. Then we are working presently on something more final to take into account more precisely the flux calibration and all the things. Michel Denfeld is working on this, and you should be able. We should be able to provide this pretty soon, typically during 2022. But at least if you want something simple, just to see if your lines are present, if you want to characterize the kind of objects you have, this is typically 1 minute.
Oh,
and
okay.
Also, I can also show you this. We can also produce images in typically the same amount of time.
Rosanne, can I make a small comment?
Yes,
please don't forget that we have 9 hours between Baja California and OHP, and we are in the northern hemisphere both. So, and we have a 2 meter. So having a joint observation between Baja California and OHP can make sense. So please don't forget this.
Okay.
It can be very efficient, huh?
Yes, I understand.
Of course, the sky, as explained by Christophe, is not exactly at OHP the sky of Mexico. But
Not exactly, Stefan?
no, not, but there is some small differences.
Yes, small.
Okay, so Margarita, I have one question. Please go ahead.
Thank you. I was wondering about the procedure to submit a proposal. Is there a particular call during the year for the visitor mode? And is there any like website to submit a TOO, or how does that work?
Okay. So typically, if you want time at OHP, you have two ways, in fact. The first one is to make a regular proposal. We have, in fact, 2 calls per year. But for this, you have, in fact, to collaborate with someone from France. The other way is, in the near future, will be to use the successor of the Opticon organization, and then some nights will be offered to this organization by this way. Probably Michel can comment a bit more on this. Last solution is also to ask for DDT to the OHP direction, and if you have the super important target of the year, you can get time also like that.
I can make a small comment. It's the French telescope, so it means that you need to find French colleagues.
Yeah, okay. It's the same here in some
I
places,
can also precise something more technical, in fact. If you make a proposal with French collaborators, you will have, in fact, to pay your part of the telescope location, renting, in fact. But it's very inexpensive. It's a few dozen of euros.
Thank you.
Okay, so I think that we don't have more questions. So thanks, Christophe, for your talk.
Thanks to you.
Now it's time for the discussion.
Wait, because no, we are going to leave the discussion for tomorrow. Stefan, do you want to comment something?
Yes, well, I can. Yes, I propose that we have a small delay. The talks on Alan has left and William also. So I propose that we, except if we have some.
Stefan.
Stefan is frozen.
Yeah, Stefan, you're frozen.
It's a proposal now.
We missed what you said.
No, the weather is very bad here, so we have some connection problems.
I don't know what I'm saying, that except if we have some special question to address now, it's better to wait for tomorrow when there will be more participants, because in France it's already late.
Yes. Okay.
It's a proposal now.
Okay, then thank you for coming today, and see you tomorrow. Bye.
See you.
Bye.
Thank you to all the speakers.
See you tomorrow.
Bye.
Thanks for everyone.
Hasta mañana.
Chao.
Bye.
Bye.
Hasta luego.